All right, so let's now look at this example. Uh, just give me 1 second. There. Okay. All right, sorry about that. Okay, so when Mendel conducted his famous genetics experiments with peas, one sample of offspring consisted of 428 green peas and 152 yellow peas. Find a 95% confidence interval estimate of the percentage of green peas. Mendel expected that 75% of the peas would be green. Given that the percentage of green peas in our sample is not 75%, do the results contradict Mendel's theory? Why or why not? Okay, so let's take a look. Maybe let's just try and understand really quick what they're talking about here. So, um, Mendel was a scientist. Um, Boy, what year was that? Hundreds of years ago. And he noticed, that green peas and yellow peas would kind of grow um, based off of certain percentages or proportions. So he was trying to understand what could be the underlying reason for that happening. So he started doing experiments where he was breeding peas to see if they would come up green or yellow. Um, and so he kind of came up with this idea that he understood maybe that there was this thing called genetics that was going on. Um, so he kind of expected that 75% of the piece should be green based off of genetics. Um, and so let's take a look at his experiment. So he had, let's see, green. He had 428 green peas and 152 yellow. So what would be the proportion of green? Okay, so what would be the proportion of green? Well, it'd be the number of green, which are 428, over the total number. So the total number would be 428 plus 152. So let's see what that comes out to be. So we've got 400. Oops, let me turn this one on. So we've got 428. Uh, Sorry about that. Let me clear. Okay, 428 divided by 428 plus, was that 152? Right? Yep. So that comes out to 0.7379. So 0.7379 and some change. So you'll notice that the proportion of green peas in this experiment, I'm just going to say equals 73.79%. That is not equal to 75%. Okay, so at this point, do you pretty much just say, well, theory says it should be exactly 75%, and it's not. So that proves the theory is wrong. That's not right. Okay. Again, nature is inherently random, and chaotic. There are unpredictable patterns associated with nature, especially like in the short term. But in the long term, this random variability can display a pattern, like we learned back when we studied probability, relative frequency versus long-term probability. So, it might just be with 400 with this number of p's. What was that? 580 p's. Just a few more came out to be green than yellow. If he did another 580, there might be a few more yellow than green, and the percentage could be a little higher. Maybe it'd be 77%. That's still not equal to 75%. Okay, so what we try to do is we try to account for this random variability in nature. And we say, okay, well, the predicted value is 75, but we want to have a little bit of variation in that. And that still is saying that the theory is sound. We just expect nature to kind of vary a little bit around that. So what we're going to do is we're going to have a point estimate, and we're going to create an interval around that point estimate. And then we're going to see if 75 is going to be inside that interval or if it's going to be outside that interval. And this interval we're going to create will be with a 95% confidence level. And the 95% confidence level just means that within this interval, this is around the typical variation in nature that we would see with a 95% confidence. If something weird was happening, it would happen outside of that interval. So that's kind of a little bit of what we're trying to do here in this problem. So I suppose I could just label this part, that this is part of our given information here. So let me try and label this maybe a little more succinctly. So we're going to let x equal to 428. This would be the green peas, and we're going to label a pea plant producing green peas as being a success. And we're going to label y as 152. Those are the yellows. And this is what we would consider to be a failure. All right, we have a confidence level of 0.95, which means we're going to have a significance level of 0.05. And sigma, or alpha over 2, significance level divided by 2 area of 0.025. And let's see here, what is our sample size? Our sample size is going to be the addition of the successes and the failures. So I think that's going to be 580. So 428 plus 152 is 580. So that's going to be our sample size. Okay. So let's put what we need. We need to create a confidence interval around the proportion of green peas here. So to calculate the proportion of green peas, it's going to be the number of green peas over the total number of peas. So that would be 428 all over 580. And that proportion comes out to 0.7379, which is what I had earlier. All right, so now we've got our point estimate. And now we have to calculate error. So when we're dealing with proportions, we're going to be using the normal distribution, which means we're going to have a z alpha 2 score. And that's going to be multiplied by the square root p prime q prime all over n. All right, so The proportion of successes is 0.7379. Let me see here. Let me go to the calculators. Okay, so I'm going to label this as P. So let me store that in P. And then I'm going to take 1 minus this answer. And then I'll store that in Q. There we go. So proportion of success, proportion of failure. That's going to come out to 0.262. So let me put that down here. Q prime is 0.262. All right. Let me catch things up here on the numworks. So let me completely back out of that. Go to calculation, clear this. All right, so what I need is 428 over 580. So 428 divided by 580. And let's go ahead and store that in uppercase P. And then I'm going to do 1 minus the answer. And then I'm going to store that in Q. All right. Looking good. Let's see here. All right. So what we need, now that we've got P prime and Q prime, and we know N is 580. All right. Now we need to figure out what this Z alpha 2 score is. So we can go ahead and draw that in. Let's do a quick sketch of a normal distribution. Here's our positive Z critical score and our negative Z critical score. Confidence level of 0.95 and an alpha over 2 area of 0.025 here in each tail. There we go. So in order to get the critical value, we need to use these inverse functions like that. And mean of 0, standard deviation of 1, area on the right, and an area of 0.025. So let's see what kind of critical value that gives us. So let's do inverse norm. Here we go. Yeah, this is a very common calculation. And I'll go ahead and store that in variable Z. Looks good. Let's go here and go to distributions. Normal distribution, okay. 0.025 on the right, so that's it. Just for the sake of being sure, and store that also in capital Z, like so. And now for both calculators, okay, so this came out to 1.960. So that equals 1.960. Okay. And then this is going to be the square root of 0.7379. That's P prime. Q prime is 0.262 divided by 580. All right, let's see what this comes out to. So we're going to have, let's see here, Z times the square root of P times Q divided by 580. And we do that here on the NumWorks calculator. So I'll go home, up to the calculation app, and I'm going to put z times the square root of p times q divided by 580. All right, so both of those are giving us the same answer, 0.0357 and some change. So 0.0357 and some change. And if we round this to maybe 3 decimal places, right here, 0.036 is our margin of error. So our confidence interval is I'm going to round this to 3 decimal places as well. So 0.738 plus and minus 0.036. All right, so if we were to put this on a number line, and if we had our point estimate of, let's see here, 73.8% here in the middle, and we were to add 0.036 to that, let's see, let's see here, 73.8 plus 3.6. Make sure that's right. Yep, 3.6, 73.8. Okay. 77.4. So we're going to have an upper bound on this interval of 77.4%. And just for completeness, we'll do 73.8 minus, to get the lower bound of our interval, 70.2. Okay, so where does 75% fit? Well, 75% certainly is within this interval. It's between 73.8 and 77.4. Okay, so we can say that 75% is within the 95% confidence interval, and therefore Mendel's theory is not contradicted by the evidence. All right. And if you were going to check this, using the interval functions on the calculators, you'd have an X value of 428. The sample size was 580 with a confidence level of 0.95. And you should get the same answer that we came to here. Okay, let me know if you have any questions.